Morning, y'all.
Y'all have been running about 20 to 30% slower than previous classes on tests. Get going. I want you to have as much time as possible.
PreCalc today, all elementary kids participating in the Jump Rope for Heart will be around the school. Phone recording. Reminder tomorrow, April 6th, 1 o'clock, early release day, and an early release white schedule tomorrow for all of you. Blocks 1, 2, 3 in the morning before lunch, all approximately 1 hour. White block 4 will be after lunch tomorrow from 12:09 to 1 o'clock. GSA meeting with the engagement room over lunch tomorrow. Everyone's welcome. Interested in playing football next fall? The parent-player meeting Thursday evening, April 7th at 6:45 in the auxiliary gym. Front doors will be open. If you have any questions, please contact Coach Wade. Fine Arts Booster is sponsoring Dessert Social during the Beauty and the Beast musical. 6 to 7 before Thursday night performance. Free will donation. Come enjoy a sweet treat. You bring in an out-of-school guest or a freshman or sophomore to the prom grand march today. Turn that form in by 8:30 Thursday morning. Tickets are being sold now, before and after school, and during sports time today. Make sure you have a ticket. Seniors, you get a free one. Many juniors get a free one, but you have to buy it. Post-prom sign-up online. Sign up for lagging behind. Remember, you must be signed up to attend post-prom. It's not a school-sponsored event. Juniors and seniors, you can go to www.spearfishpostprom.com. Takes place in the middle school, begins at 11, right after the date. It is free, but you have to sign up. Vegas-style games, trampoline, laser tag, inflatables, food, lots of prizes. If this show ends the evening, usually around 1:30. Remember, your guest names must also be submitted by Wednesday, April 6th. Be sure to sign up. Juniors, make sure you sign up to decorate for prom on Friday. If you're called in to be excused, you can do 1 block, 2 blocks, 3 blocks, or all 4. It is an exempt absence. You must be eligible. Contact Mrs. Watterson if you have any questions on the prom decorating on Friday. All, please stand for the pledge. To the flag. And to the republic for which it stands, one nation, under God, indivisible, all.
Who's still going? Zoom, zoom. Minute to win it. Should be relatively quick. Talked about yesterday, because our unit circle and our special measurements are all broken up in increments of pi over 6, pi over 4, and pi over 3, pi over 2, then the denominator just straight up tells you what the reference angle is. Pi over 3. 4 pi over 3 is down in quadrant 3 and forms a pi over 3 60-degree angle with the x-axis. So, since I know the sine of pi over 3 is square root of 3 over 2, and because I'm down in quadrant 3, all students take calculus, sine is not tangent, so this has to be negative. Tangent of 450, well, 450 is more than 360, so subtract 360 and get, ruh-roh, 90. So its reference angle is 90. That's the biggest a reference angle can be, by the way. And if I look at it in terms of coordinates, I'll have the point 0r with a radius of r. So if I use my XYR shortcuts on there, tangent is opposite over adjacent, or y over x. But if I do y over x, I get number over 0. You can't do that. Cotangent of 7 pi over 4? Well, it's got that pi over 4 on it, so pi over 4 I'll loop all the way around, counting by quarters until I hit quadrant 4. 7 pi over 4 forms a pi over 4 angle with the x-axis. If it forms a pi over 4 angle with the x-axis, then I'm looking at the tangent of pi over 4, which is 1. The cotangent is the reciprocal of that, which is still 1. And because I'm in quadrant 4, all students take calculus. Tangent is not cosine. So this one also needs to be negative. Okay? So we're going to do, it's still out of 5. But there were 6 things. So what I'm going to say is each one is worth a point. If you got all 6 wrong, you just deserve the 0. Okay? So if you got 2 wrong, 3 out of 5. If you got 3 wrong, 2 out of 5. Okay? Because those should be, by now, I said, you got to know your circle, you got to know your special trig ratios. You have to know them. Because we didn't make it quite as far as I wanted to yesterday, we were so close. Like when you build the unit circle, it just, you are Neo getting up off the floor. You can see the matrix. You stop bullets. Wait a second. You mean it's all just special right triangles? Once you have the unit circle, it is the holy grail of trig. And we were right there. Once you have it, then it's just look at the friggin' circle and that's your answer. Okay? We were close. Which means today, we're going to do our test. And then tomorrow, we'll build the unit circle and finish off those last few examples from 4.3. So Thursday, you will have your Do You Know It quiz. No notes. We will start with that. No notes. Here's a piece of paper. Fill it out. Okay? And then we'll jump into 4.4. All right. Well, before we get to that, I mean, no one asked any questions, but do we have any? We have a contestant.
Yeah, I have 20.
20. I volunteer as tribute. All right. What am I supposed to do with 11 pi over 3? Oh, is that the, like, draw the angles thing?
Yeah.
Okay. So, womp, womp. See, the problem with 11 pi over 3 is that it's more than a circle. So, subtract 2 pi, which is 6 pi over 3, getting 5 pi over 3. So that at least tells me where it is. Okay, is it do the positive and negative coterminal thing with it? Because that's actually going to be easier. If 11 pi over 3 is the original angle, then a positive coterminal angle is just 5 pi over 3. Because it is positive. So 11 pi over 3 is all the way around the block and 5 pi over 3. But it ain't 5 pi over 3. It was 11 pi over 3 because we already went around. What happened here was normally I'd have 5 pi over 3, get a negative, get a positive. What they've done is swapped the original and the positive coterminal angle. They just swapped them. Remember, when I'm saying find positive and negative coterminal angles, you could draw 30 circles around this thing if you wanted. As long as it's a positive angle or a negative angle as indicated, you're right. Watch yourself today. Finn, I'm looking at you. If you decide that you want to do all those circles, you better be right. You better be right. So, if this is 11 pi over 3, What? I always have problems with 11 pi. I write 11, 11, or I write pi, pi. Okay, 11 pi over 3 is around the block and another 5 pi over 3. That means my positive coterminal angle can just be 5 pi over 3. Right? They're both positive, and they both end in the same spot. So I'm allowed to say that. My negative coterminal angle is going to be very related to those reference angles. Go the other direction. So if I go 5 pi over 3, how far would I come down this way to hit it? 1 pi over 3. But it's going the other direction, so negative. We're so used to negative as meaning like opposite or just, I don't know, it's something in front of a number. Like, we're starting to see more that negative means direction. Negative means opposite. If standard positive is go this direction, then opposite means go the other direction. Had a couple come in this morning and they were asking again about if I have a coordinate xy and they draw their triangle, why is this a negative number and this is a positive number and this is a positive number? When is it positive? When is it negative? This is distance from 0. Remember good old distance formula? Distance can't be negative. Also, distance formula is Pythagorean theorem. Pythagorean theorem has things squared. If things are squared, then they're always going to end up positive. But these are denoting direction. That y being negative doesn't mean opposite or absence of, it means down. That's all the negative means. This one was, we've talked about it enough times that I included this on the assignment to see if you could reverse the clock instead. But, utters. Okay. Review time, here we go. Round 1. Fight. Solve the triangle. Solve means I give you 3 things, you have to find 3 things. The 3 things you're going to find, you have to find as exactly as possible, meaning if you can write it as an expression, write it as an expression. If you can write it as a simplified fraction or radical, write it as a simplified fraction or radical. So I'm given 2 sides of a right triangle, find the third. How? Pythagorean. I find leg is square root of hypotenuse squared minus leg squared. So I'm going to say that's a square root of 35 squared minus 20 squared is 35, 90, 900, 5, 150, 300, 12, 25 minus 400, 825. Take out a 5 square root of 30 what? Oh. We're getting close. Make sure you write it as a simplified radical. It's going to be tempting to maybe find one of these angles, and then if I found angle A, say tangent of A is this over 20, that gets you a decimal answer. It's not as exact as possible. If you can solve it by Pythagorean, do it by Pythagorean. Okay, now go find the angles. Again, you don't want to use this because that's something you just found. What if I found it wrong? Now I domino effect into the rest of my problem. But if I instead say the measure of angle A is, and use only the information I originally had. I had a 20 and a 35. Those are opposite, adjacent, or hypotenuse from angle A. Adjacent hypotenuse, which is cosine. And to find angles, I don't use cosine. The inverse, or arc cosine, of adjacent over hypotenuse. If you leave it as 20 over 35, I'm fine with it because those were the values on your triangle. If you want to reduce them down to 4 over 7, also cool. Remember, this is a ratio. A ratio stays the same regardless of how big it is. So whether you say 4 over 7 or 20 over 35, it's going to give you the same angle. What mode are you in? If you want to be facetious, if you want to write your answer as an irrational coefficient of pi, you can, but you better say radians. Most of us, on the other hand, would rather do this and then just keep it in degrees and say it's about how much. It rounded up like that? Okay. Now, I need to see that for either angle A or B. I don't care which one you started with. You got to find one of them. But to do the second one, you could write another expression like that. I could say B is the arc sine of 20 over 35. Or, if you just said the measure of angle B is 90 minus measure of angle A, and then in your calculator, 90 minus answer, also cool. Okay? So I don't care which you do, but I caution you to not just rely on the calculator and only do things in the calculator and then write an answer with nothing to back it up. At the very least, write what did you do? What did you type? Because I would like to give you the partial credit if it goes awry. Okay? Words! If you want to do stick figure drawing, you go right ahead. It is not necessary. But Sarah stands on the ground, sights, looks up at a cliff, 60 degrees. She steps back 50 meters. Now she sees it at 30 degrees. If Sarah is 1.8 meters tall, how tall is the cliff to the nearest meter? Okay. Now, I know that this has 30 and 60 on there. You can solve this with 30, 60, 90 ratios. I'm telling you that all forms of the test are not 30, 60, 90 or 45, 45, 90 ratios. So let's do it the real way, the system way, so that you have something to look at. Okay. Stick figure Sarah sees cliff at 60 degrees. Stick figure Sarah backs up, sees cliff at 30 degrees. She backed up 50 meters. What I don't know is how tall the cliff is or how far she was originally standing from it. But I do have enough to write out two different triangles. In the 60-degree triangle, I have the tangent of 60 is x over y. And I think you see why this makes me uncomfortable. I should immediately be writing tangent of 60 as, do we know tangent of 60? Square root of 3 over 3. No, it's square root of 3. You're right. You're right. Okay. So I want to do that, but I'm not going to because it's not going to help you with when it's not these. I'm also going to have another triangle when she stands further back where I've got the tangent of 30 is going to be opposite over adjacent is now all of 50 plus y. We said that we can make these go faster instead of cross multiply and divide by using that idea that I can swap means and extremes in a ratio. I can just flop those two and say y is x over tangent of 60. I can flop those two and say y is x over tangent of 30 minus 50. Right? Because it's going to be 50 plus y. And then I subtract the 50 over. So if y equals this junk and y equals that junk, set junk equal to junk. I've got x over tangent of 60 is x over tangent of 30 minus 50. Do we remember how? X is on one side and factor. That might be a good note to write to yourself. Is that if I have 1 over tangent of 60 minus 1 over tangent of 30, they're both going to have x's on top. If I just factor the x out, then I can divide. Right? They're both going to have an x on top. So I factor x out, leaving a 1 on the numerator. Now, I'm not going to make you simplify that expression. In fact, I was talking to someone just this morning who writing these expressions like this just really bothered them. That's where my 3 places rule came from. I had kids in geometry, because that's where this came from. I had kids in geometry who just could not write this for the life of them. So I had them way back here do 1 over the tangent of 30 in their calculator, run it out to 3 places, and say point blah, 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 x. And that just worked better for them. If you need to do that, okay? But I divide by big ugly thing. I get x is negative 50 over 1 over tangent of 60 minus 1 over tangent of 30. You can do that in pieces. You can one-shot it in the calculator. I don't care. But that gets me x. And then I don't need y, but there is something missing. This is still a 4 out of 5. Well, yeah, once I have the decimal approximation. The decimal approximation gets you 4 out of 5. What's missing? Add 1.8. Stick figure Sarah's 1.8. If they include the information, you have to take it into account. If they don't include it, you don't have to worry about it. They told me stick figure Sarah's 1.8 meters tall. So whatever I get here, I'm also going to add 1.8 to it. Y'all going to be really annoyed in about 2 weeks when we go back and review law of sines and cosines. It's so much faster. But, you know what? I'll tell you, if you remember law of sines and cosines, maybe you did a little bit of investigation off to the side to say, hey, I remember this. Use it. Makes that problem take 30 seconds. Okay, speaking of coterminal angles. I have seen over and over and over and over, kids will do the draw and label, and they'll completely miss this first line. Determine all angles coterminal with. What is that? How do I say every single angle that's coterminal with this? That almost sounds like integers. The n thing. Remember, it's alpha plus 360n, where n is an element of the integers. Or if it's in radians, alpha plus 2n pi, where n is an element of the integers. That tells me all of them, because as soon as I say n is an integer, I have covered the entire set of integers. I've even covered that facetious kid who wants to do 120 laps around the circle, because 120 is a integer. Okay, so you got to say one of those. In this case, because it's in degrees, all I do is change this to negative 225, and I'm good to go. Then draw and label. Womp, womp. So my original angle, negative 225, what quadrant we in? Negative 225. We are in quadrant 2, yes. Because you're going to go this way, well, that's 180. Go another 45. You're at negative 225. But wait a second, I don't want negative 225 because my directions say in radians. Don't you say negative 225. What is that in radians? If you got to do the conversion off to the side, that's fine. Negative 225 times pi over 180. Five pi over 4. Right? Didn't I go 1, 2, 3, 4, 5 parts of a calzone? Then, positive coterminal angle. If I take negative 5 pi over 4 plus 2 pi, which is 8 pi over 4, I get 3 pi over 4. If I take negative 5 pi over 4 and I subtract another 2 pi, or 8 pi over 4, I get, there's 5 pi over 4. Keep going around the block and try it again. Now I'm at negative 13 pi over 4. Yes, I will accept anything that is correct and coterminal if you want to do more than just the next iteration of coterminal. Said I got the kid. I threw away the tests. I finally shredded them last year. I want to say the kid got up to like 80 some rings before he just ran out of room. Okay. Is there anyone who does not know how many inches are in a foot? How many feet are in a mile? Like, do we know those things? How many seconds are in an hour? Okay. If we know those things, do you know basic, do you know metric conversions? How many centimeters are in a kilometer? Could you go centimeters to meter and then meters to kilometers? Cent, 100. 100 centimeters to a meter. Meter to kilometer. Kilo, 1,000. Okay? You got to know those. If you do not know direct conversions, you may ask. But clock is divided into 12 sectors, each with an angle of pi over 6 radians. What is the angular velocity of the minute hand in radians per minute? So I want you to think about a minute hand. It makes a full lap. A minute hand does one revolution in how long? 60 minutes. Or you could have said 1 hour and then converted that, right? You take what you know about the concept. One revolution takes 60 minutes for the minute hand. All right, I got something to work off of. Here we go. What is the angular velocity of the minute hand in radians per minute? Might not have been a bad idea that I started in minutes because I already have one of them. All I need to do is change my revolutions over to radians. One revolution is how many radians? 2 pi. I don't care about decimals. If all you do is tell me that this is pi over 30 radian per minute, that's what I'm looking for. Okay, if you want to have a decimal approximation with it, you go for it, but that's the one that I'm looking for. What is the linear velocity of the second hand in feet per hour if the second hand is 10 inches long? Ooh, now they're talking about a second hand. So take what you know about a second hand. Does one revolution in how long? 60 seconds. Can I just call it 1 minute? Because I need to go over to feet per hour. Right? You can start in seconds or minutes. It doesn't matter. You just have to get to the same place when you're done. Okay, 1 revolution per minute for the second hand. If I want to go over to feet per hour, well, I need 60 minutes is 1 hour. Minutes. I'm now in revolutions per hour. Do you remember what was the magical gateway, the portal, customs, to go from linear over to rotation, to go from rotation over to linear? A radian is a radius. I don't have anything about radians or radius right now, but I do have revolutions. Convert revolutions over to radians. 1 revolution is 2 pi radians. I am now in radians per hour. I want feet per hour. I have radians. I have my passport. I am at customs. I am ready to go through the gate. I can now go through the magic portal that says 1 radian is 1 radius. And 1 radius is, in this case, 10 inches long. That's the second hand. Okay. And now it's back to business. We're in inches per hour. I don't want inches per hour. I'm going to turn 12 inches into 1 foot, and then I'm going to change 5,280 feet into 1 mile. Oh, wait, we want feet per hour. Never mind. Not miles per hour, just feet per hour. So, womp, womp. I multiply all the way across. 6 by 2 by 10. 65, 120, 1,200 over 12 is 100. Right? And then if you want the decimal approximation of it, oh, hold on, feet per hour. If you want the decimal approximation with it, you are welcome to. Okay, so what you're going to have for number 4, one of them is just going to be a straight conversion of this to this, linear stays linear, angular stays angular. Part B is going to have you swap from linear to angular or angular to linear. You will have to cross that boundary. Okay, sketch the angle, find its reference angle, find the exact value of the 6 trig functions. So, tangent of theta is 8/3. Tangent was positive. Cosecant was less than 0. That's negative numbers, but cosecant is a reciprocal of who? Sine. So that means that the sine was negative. I leave these up for a reason. Okay, former PreCalc teacher, these were hiding in his closet because he said any form of notes was cheating. You came in blind to every test. It was timed. They were about 30, 40 problems. If you didn't finish, the rest were zeros. He was an angry, angry person. Where is tangent positive but sine is negative? All students take tangent quadrant 3. So go make an arbitrary triangle in quadrant 3. If you need your axes to help you get to quadrant 3, if you need that just to understand where my triangle's going, that's fine. Okay, so this is actual theta. Theta prime, if tangent is 8/3, well, opposite over adjacent. Those are wrong. I'm in quadrant 3. Negative, negative. Tangent is still 8/3. Negative 8 over negative 3 is positive 8/3. But I have to remember that. Okay? Now, again, year after year, I'll have a problem like this and kids will not find the reference angle at all. The reference angle is the positive angle formed with the x-axis. It's theta prime right here. How can I find that?
Don't you just do the inverse?
Yeah, just do arctangent. So I'll say theta prime is arctangent of 8/3. I could do negative 8 over negative 3, but same difference. And then whatever that is. Make sure you're in degrees.
Will we need to switch our calculator to radians for anything?
Nope. In fact, the stuff that we have to do in radians, your calculator won't do for you because radians need to be in terms of pi and your calculator won't do it in terms of pi. It'll just give you decimals. So there's almost no reason for you to be in radians on a graphing calculator. Who?
Why do we have to switch it every time? Why is it set up?
Because in all upper level math, you are in polar coordinates and radians. And now, when you move on to trig, and you are talking about trig and physics, particularly, and you're talking about radians and in polar coordinates, then yeah, you're going to use them a lot. Right now, no. Like this is the border. This is the radians equals radius customs gateway between high school math and not high school math. So you do the thing, you poke the buttons, you get the angle. What's missing from this in order to find all my trig ratios? Hypotenuse. Hypotenuse I find by Pythagorean theorem. Square root of negative 3 squared plus negative 8 squared is 9 and 64 is 73. And that cannot be simplified, so we're off to the races. Sine, cosine, tangent, cosecant, the secant, the cotangent. Sine, opposite over hypotenuse, negative 8 over square root of 73, rationalize it. Cosine, adjacent over hypotenuse, rationalize it. Tangent, opposite over adjacent, we already knew was 8/3. Flop it for cotangent, 3/8. Instead of flipping sine, cosine over to their reciprocals for cosecant and secant respectively, instead I would just use the definition because it's faster, there's no rationalizing. Cosecant is hypotenuse over opposite. Hypotenuse over opposite. So it's just negative root of 73 over 8. Hypotenuse over adjacent, negative root of 73 over 3. I'll tell you, time after time again, year after year, I will see kids who draw their triangle in the right spot. They get all of these. They don't find that reference angle at all. Or for some reason, they'll find all of this correct, but then they'll draw their triangle in the wrong quadrant. Okay. All right. And finally, I was torn between doing a review problem on factoring and complete the square for polynomials versus formula plug and jug. And then I timed it and formula plug and jug. Okay. So find the arc length AB and the area of the unshaded region. You have option. Arc length is either pi r squared times x out of 360 or radians times radius. You have area of a sector is either, wow, surprised no one caught it. Whew. Pi r squared times x out of 360 or 1/2 radians times radius squared. You have a choice. Depends whether you like the radian or degree version of the angles you're talking about. So your arc length in this one could have been 2 pi r. They use decimals, so they set the precedent. You're allowed to use decimals. 12.8 by arc length AB. I'm going from there to there, so I will use 110. Or radians was just, if I take 110 times pi over 180, it's just 11 pi over 18 times 12.8. Whether you're in degrees or radians, I don't care. You're going to get the same answer. The answer is going to have pi in it. If I'm looking at my area, watch the wording. What happens when I say unshaded on here and shaded on your test? Okay, just watch the wording because I don't remember which it was. I'm going to have pi radius squared by unshaded region. If there's 110 that's shaded, 250. Subtract from 360 and get there's 250 unshaded. Or 1/2 radians would be 25 pi out of 36 by 12.8 squared. Yes. Yes. Get your calculator mojo, write it in terms of pi, and you're good to go. Tie game in the fourth quarter. I had a really, really bad second hour the day that I had like 3 hours of sleep. They just crushed me like 2 days in a row. It was pretty bad. So, you know the drill. We got lots of time. Phone's over meow. Mix yourselves up. We got our other tables back. Hey.
You just, like, we can leave pi, like, simplify it down and leave pi.
Just jam this into your calculator without pi.
Oh,
And then just write thing pi.
okay.
Yeah.